Hi all, welcome to TechChain. Today I'm going to share basics of Ethernet header. Let's go into the topic. Ethernet header, there are different types and standards of Ethernet header. We can see Ethernet 2, 8, IEEE 802.3, which we can also call it as 802.3 LLC. It's a logical link control which belongs to both physical as well as the data link. 802.3 SNAP and Ethernet RAW. DIX is it's initially introduced by three vendors, which is a Digital Equipment Corp and Intel Xerox. So they named it as Ethernet 2 DIX. As we know in the market, we have different Ethernet cables like coaxial cable, twisted pair cable, fiber optics cable. So if you see the coaxial cable, it supports from 10 megabits per second, 100 megabits per second, and fiber optics starts from 100 megabits per second to 100 gigabits per second, and nowadays it supports 400 gigabits per second. The latest release is 400 giga Ethernet, and it was released on September 2022, which is 802.3 CK standard. So these cables mostly used in advanced form of cloud infrastructures. So uh, this is the bandwidth. 400 gigabit Ethernet is the bandwidth, and let's see the fields in Ethernet header. So these are the basic fields in Ethernet header. So initially when switches was not introduced, so we have only hubs, repeaters and bridges. So that moment we have only the six fields like preamble, destination address, source address, type, data, FCS. So the preamble, which is a 8-byte information, and from IEEE 802.3, this preamble is divided into two fields, SOF, which is the start of the frame delimiter. We can also call it as start of the frame. So it indicates the starting of the frame, and preamble, what it do, it synchronize with the physical layer. Physical layer, as we know, the data is in the form of bits, zeros and ones, and it synchronizes with physical layer from data link layer. And if you see destination address, which is a 48-bit MAC address of the destination, followed by source MAC address of 48-bit, and type, it indicates the layer 3, what kind of a layer 3 protocol that we are using. Either it's IP protocol or AppleTalk or IPX. So nowadays mostly we use only the IP protocol, either it is IPv4 or IPv6. And data, the kind of a data that is encapsulated from the higher layers. And FCS, which is a frame check sequence. So what it do, it runs the algorithm and uses CRC, which is cyclic redundancy check. So at sender side, it runs the algorithm of all the fields and it keeps the value in the FCS field. At receiver side, it runs the same algorithm and it checks the values of the sender side. If it matches, means there are no errors. If not, it means that there is an error in the frame, so it discards the frame. Again, we need to resend. And if you see, as we told, preamble, initially preamble is combined with the start of the frame, and from 802.3 when it introduced, so start of the frame is divided, and if it ends with 111 means that the frame is going to be started. I mean, it's ending the frame. And if you see header and data here, from when switches involved in networking, So we have VLANs, trunking, STP protocol, DTP protocol. We are using a lot of protocols in data link layer. So that information like VLAN information, trunking information, where it keeps? It keeps in the header. So the data or padding field is divided into header and data. I mean it renamed into header and data. So here it keeps the VLAN information or trunking information or DTP. That information is present and send the frame. And this is the fields. As we know, preamble, what it do? It uses to synchronize with the layer 1 and start of the frame, which uses to inform the receiver that it's sending the frame. Destination address and source address, which are the MAC address of the sender and receiver. Type, what type of a protocol that we are using. Data, it keeps the encapsulated data from the higher layer. Either it is IPv4 packet or IPv6 packet or AppleTalk or IPX. Payload, it keeps what information that received. It keeps in the payload. FCS, as I told, it runs the algorithm and adds the value and keep it in the FCS field and checks at the receiver side. What it do? It uses to detect the errors. DSAP, if you take the IEEE 802.3 snap header, you can see these fields: DSAP, SAP, control byte, and OAI. DSAP is nothing but destination service access point. It's act like a memory buffer. It keeps the receiver station address in the memory buffer. Source app, which specifies the source of the sending process. And control byte, what kind of LLC information that we are sending, it keeps that information. OUI, it keeps the first 3 bytes of the source MAC address. Sometimes it keeps the 0. So we don't need to dig much deeper and deeper in fields. We just be aware of the fields, what fields Ethernet header is carrying, because we are not the developers to deep much deeper and deeper. Just learn the basics. That is more than enough for network engineers. And if you see Ethernet header, these are the 3 varieties of the Ethernet header. This is the basic one. If you are aware of this Ethernet DIX and Ethernet IEEE 802.3, that is more than enough to learn the basics of Ethernet header. And this is the simple topology which I have created. And we have 2 switches and 3 PCs where I have already assigned the IP address on PCs. And switch have a base MAC address and each port have a different MAC address. Now we are going to ping PC0 to PC1. First, we will check what are the entries on it. Let's go to the command prompt and now let me check the arc table. So we don't have entries. Now let's ping 10.0.0.3. Okay. So if you see, we have 2 packets. Let's see what are those packets. One is ICMP and ARC. These are the packets that I have filtered in the simulation mode. So let's see what is ICMP. ICMP have layer 3 information from source to destination. And if you see the outbound, it have only the IP header and ICMP information. So this is the type of the ICMP value. And let's see what information of the ARP packet is holding. It have layer 2 information. This is the MAC address of the source, and destination we are not aware of 10.0.03 where it's there, so it's going to broadcast with the address of FFFF. Okay, that is the outbound packet. Let's see how it goes. So it went to first switch. Let's see what information it's holding now. This is the inbound PDO and this is the outbound PDO. So even switch was not aware of the destination MAC, destination IP address MAC, so it's going to broadcast. What switch do? If switch was not aware of the destination, it broadcast to all other ports apart from the port which receives the information. Okay, and outbound information from the switch it going to broadcast by the source IP address of 10.0.01 and destination it looking for the MAC address of the destination 10.0.03. Okay, so it going to broadcast to FA0/1 and FA0/3, not to the FA0/2 because it receives the information from PC0. Now it broadcasted and at PC2 the packet was dropped. Let's see why it dropped. Because it looking for the destination MAC address of the IP 10.0.03, but this PC is having an IP address of 10.0.02. So this PC was drop this packet. Hey, I am not the person whom you are looking for the MAC address. So it drops the packet. What this switch do? Even this switch was not aware of the MAC address of 10.0.03. It's going to broadcast to other ports apart from the port which receives the information. So apart from this, it's going to broadcast to this port. Now what happened? This PC receives the information. This PC have 10.0.03 which is the right MAC address. So what it says, hey, I am the person whom you are looking. This is my MAC address. If you see this 00E0, now this PC is going to reply back as I am the source now. I am going to reply it to 10.0.01, which this is my MAC address. Hey, 10.0.01, I am the person whom you are looking. My MAC address is 00E0.F9B2, this one, which I have the IP address of 10.0.03. So here onwards, it reply back with the same MAC address. See. So initially switch broadcast the frame, but now switch also aware of this MAC address. It keeps in the MAC table. Okay. See. In ICMP packet, it clearly mentioned from 003 to 00E0, which is the MAC address of this. See, source address, destination address. Okay, if you see the ARP packet, it have the source IP of 10.0.0300E0 and destination IP address of 10.0.001 is 0030. Okay, and now let's see the ARP entries. See, we have the ARP entry. In case if PC want to ping back from PC0 to PC1, what it do? It directly send the information. First ICMP message. Okay, layer 2 header. We already know that this 10.0.03 address is 00E0. Okay, so here onwards it won't broadcast. It directly send to switch. See. Even switches was aware of it. Let's show you that. Show MAC address table. See, 0030, it comes from the port FA0/2, 007 EC2, which this is the, to reach this PC, this is the endpoint, source point for this switch. So from which port it receives? FA0/1. Okay. So as we saw, Ethernet field have a type field. So as we saw ICMP and ARP fields, if it is a ARP information, it have the value of 0x0806, and for ICMP we have seen the type as 0x0800. So the same, if it is IPv6, this is the value, and for 802.1q, which is used for trunking protocols, and we can see it, we can learn in upcoming sessions. This is the basic mind map for Ethernet header. So if you see the Ethernet header, what types of Ethernet header and what are the fields in that. So preamble, start of the frame delimiter, destination, Ethernet header, source, Ethernet address, and length, type, data, frame check, sequence. These are the fields in Ethernet frame. If you like this video, please do like, share and subscribe for more upcoming videos. Thank you so much for watching and stay tuned.